BCA 101. This is beginning of the second half of the term, and we are going to do some work with communications and networks. We will use some curriculum from Cisco Netacad, and in class we'll go over how to access that. So what we have here is a diagram that will refer to different parts of it. If you remember previously, we showed a cloud showing the IT area, and that cloud connected to what would be a bigger cloud, and this was the Nyack campus, and that connected in to the internet. So it's similar to what we have up here, except now we're taking this part and showing some specifics. The same thing here, this part, and showing some specifics. And then later on we'll look at some specifics inside the internet. So here's where we're at. In the labs we have PCs connected via a medium, cable, to the network. We also could have, even though we don't, but a student could connect their laptop that way. Or you could be in the room and you could have a device like a phone, and that device could connect in to an access point. It's actually one out in the hall, and that would connect into a different part of the network here at the college. What we connect to is a device called a switch. We showed this in the room. That switch then has a connection to a device we call a multi-layered switch, which acts as a switch and a router. We learn a little bit more about routers later on. And so this device is in a wiring closet in close proximity to the room. This device is actually in the classroom, as an example. This wouldn't be also different in a lot of businesses. Also, we have an access point for wireless communications in our area. For example, I may connect to that with my laptop using Wi-Fi. Okay? We then have a connection to a router, and this router acts as a firewall for the IT area. Then there's a connection. This connection is actually fiber optic, goes over to another building in which there's what would be called an edge router, and that edge router has a connection to the ICN. It's actually fiber, runs around the building, goes down to Highway 60, goes down to the highway to the south, and then eventually down Highway 65. It connects to the ICN into that fiber network here in Iowa, and they connect into the internet. Okay, and at the college here, they also have a firewall device, and they have a multi-layered switch, and then from there are connections going all over campus. All over campus. There are some other devices in here too that we can talk about a little bit more later on. But there are switches in different areas of the building, and you can connect to those using devices like there's printers connected. So we have all these end devices on the end of our communication. For example, here's a phone connected into an access point here on campus. There are some, 100 access points spread out throughout campus to give us wireless communication, and we're going to refer to that as Wi-Fi and learn a little more about it later on. So you can see, then we have the campus part of the network connected to the internet. And this wouldn't be so different at other businesses too. They would have a firewall to their connection into the internet, and they might have a multi-layered switch here that allows them to communicate, their switches to communicate to devices at any business. You know, Amazon, this would be much bigger. The devices would have huge hard drives and organize their data. And other places like a small business, this would maybe little. And the same thing's true even at my house. There's some device, cable modem, and connects to a little device, a little router. With that router acts as an access point, it acts as a switch, and it acts as a router, all in one. Okay, so to the next page, and you can see I have the other half of the diagram. A couple terms I'll just mention briefly here. Protocols, rules for transmission. There are certain protocols that are used. For example, the Wi-Fi 802.11, that's a little bit different protocol than Ethernet that connects the devices here. Different ways of communicating, okay? The media is what we communicate across, and we already talked about this. Wired, wireless, or fiber optic. Now, how does a message from one device, like this device here, or let's say a device at my house, say a tablet at my house, using wireless to connect into the router and so forth, how does that connect to, let's say, some server like Angel here at NIAC? There's an Angel server sitting here at NIAC, and I can use my iPad and I can go through and connect to that. Well, it's done with addressing. Each device, each end device on a network has a physical address in the world. It's called a media access control. It control access to the media. Kind of makes a lot of sense if you think about it. But it's considered a physical address. It's in the device, and it's unique to the device. The manufacturers put them in. So this phone has one, this iPad has one, every computer has one. In fact, all kinds of devices in the world have this physical address. It's a 48-bit address, and it's right in the devices, and it's unique to every device. Now, it depends on where the device is. Like my iPad here at home will get a different logical address than it would when I have it here on campus. And I connect into the Wi-Fi on campus, it gets a different logical address. And the logical address is the protocol that's used. We mentioned protocols. Protocol we use now is Internet Protocol. So you get a logical address. It kind of refers to, so to speak, where you're at in a way. So ISPs, like the ISP Mediacom, they give my router an address. It's a public address that can be used out on the internet. Internally, my router gives my device a private address, a private IP that can just be used locally. And then later on we'll learn when my device goes out to the internet, my inside address is converted to the public address. Okay, and then I have a public address for this server. I'm able to go to the server, come back, and get the information back. And it's all done with addressing. Now we're going to talk more about the specifics of that as we go on through the communications. That's it for today.